Hello. So let's come back again to our problems. It's the third tutorial. We are starting with real numbers. Okay. So here I would like to discuss some of the basic definitions, which, of course, I should have discussed earlier only. But anyway, that's not an issue. Anyhow, we should be aware about that particular problems or definitions. Okay. So quickly we'll go for some recap. Okay. Some important recaps. Prime numbers. A natural number is said to be a prime number if it has only two distinct positive factors. What are they? 1 and the number itself. We have to precisely talk about the positive factors. So you can write many examples. For example, say 3, 5, 7, then 9 will not be prime, it is odd, 11, like this, and the smallest is 2, and so on. There will be infinite number of prime numbers. Then composite number, a natural number which has more than two distinct positive factors. It should be more than two distinct positive factors. So the smallest composite starts with 4, then 6, then 8, then 9 will come, right? Then your 10 will come, then 12, etc. Okay. Some of the students sometimes in hurry they say that those numbers which are not prime are composite, but that will not be correct, because you can see there is a very special number 1. It is neither coming in this category of primes nor category of composite. So 1 is such a number which is neither a prime nor a composite. So you cannot say that composite number means those number which are not prime. Okay. Then next is twin prime. Twin prime means two consecutive prime numbers whose difference is 2, right? Just say you cannot get these as twin prime. 2 and 3 are not twin prime. Well, 3, 5, 5, 7 you can say. Then after that 11, 13, right? Then 17, 19, like this, many more pair you will get. Okay. Next, some important recaps again. Relatively prime or co-prime. Relatively prime number or co-prime number. So two natural numbers are said to be relatively prime or co-prime. Both are giving you the same meaning, relatively prime or co-prime, if the HCF of these numbers is. Be very sure you need not have here both the natural number to be prime numbers, right? Even they need not be prime numbers. Their HCF should be only 1. Just say, okay, any two prime number will obviously be co-prime, but even composite number, right, may be co-prime. Just say 4 and 9, they are composite numbers, right, and they are co-prime. Am I clear to you? So likewise, say 12, and then 12 के साथ कौन सा co-prime हो सकता है? 25. So 20, 12 and 25 are co-prime. Why? Because they do not have any factor other than 1. Okay, what I explained here, they have written as a note. 1 is neither composite nor prime. Next, let us start with very important part after your Euclid's division lemma. It is a fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Every positive integer can be expressed as the product of its prime factors, and this representation is unique as regard to the occurrence of the prime factors. So first of all, let us try to understand exactly what does this statement says. It is very important. It is very easy in fact, but very important and particular statement. So let us start with an example. For example, supposing that somebody asks you to factorize this. So how do we start factorization? By dividing it with the help of the smallest prime factors. And this is the normal tendency, right, or normal process taught to us, that you should always start first the division with the help of the smallest prime and then go on increasing. But okay, anyway, I'll be discussing. But now, before I proceed, let us see how many 2's are there. There are 4 2's. If you write it like this, so you will write it 2 multiplied 4 times, then 3 multiplied 2 times, then ultimately this will be here like this. Okay. Acha. Suppose there is a student who is something like this. First, so they have divided by 72, and suddenly they feel, no, I know that it is divisible by 3, so let us divide by 3. Then again by 3, 8, and then now he is dividing this by 2. Now I have a question. Should I say that this student who is performing like this is wrong? Obviously not. Because even if he did not continue with all 2 factors first, but ultimately you can observe that whatever number he has split it up into this 144, you will find the same number of 2's and same number of 3's. It is immaterial whether he has started his division by 2, 3 or whatsoever, but ultimately when you try to count the number of prime factors, it remains same. That's what the meaning of this second line is. That means it is immaterial whether you divide like this or divide like this. Ultimately, your representation will be same, right? That is unique, right? So that's what they are saying. So this uniqueness is very important, because this uniqueness guarantees us that in no way how you divide, ultimately a particular number will have a particular given primes as its factors. Okay, this is the next. Prime factorization. Okay, the expression of any natural number as the product of its prime factors is called prime factorization. That means whenever you express any natural number as the product of its primes, then it is prime expression or prime factorizations. Okay? Just say 12, I can write it as 2 into 2 into 3. And now, as we know the exponent, we will write it like this. So this way, if anyone will write, then we call this prime factorization. HCF. We already did problems. Highest common factor. For any 2 numbers A and B, highest common factors are nothing but product of the lowest powers of the common prime factors of the given numbers. Common prime factors. I'll discuss this problem, but already we have solved in the slide 1, that is first the tutorial, so you can go back also and you can see. And then when you go for lowest common multiple, okay, we did not discuss lowest common multiple that day. It is for any 2 numbers, it is the product of the highest powers of all the factors, all the distinct prime factors. I'll pick some example for this particular one, right? First, let me go for the next slide. Okay. HCF is also called GCD, greatest common divisor. Greatest common divisor. HCF of 2 number is always positive. Very, very important things you have to remember. and then this is important result. This is very important result. Please do mark this, otherwise you may miss some problems. For any two numbers, remember it is valid only for two numbers. HCF into LCM is equal to product of the numbers. HCF into LCM is equal to product of the numbers. HCF into LCM is equal to product of the numbers. So in this equation there are four quantities involved: HCF, LCM, A and B. So out of this, if someone gives you three, that means three quantities, then the fourth you can find, right? Okay. Now let us start with questions, and then we'll be discussing one by one. Can 6 to the power n ends with a 0 for any integral value of n? Why? Whatever may be your answer you have to give reason, right? Okay. Let me directly start with this. Now 6 to the power n, 6 can be broken into prime factor as 2 into 3, which ultimately will be written like this. Now what will imply? Uniqueness, right? Clearly uniqueness of, right, prime factorization of 6 to the power n implies that 6 to the power n has only two prime factors. They are 2 and 3. So we have only two prime factors for 6 to the power n. Now observe one thing. If a number is to end with 0, it must be divisible by 10. And if it is divisible by 10, then very necessarily it should be divisible by 2 and 5. It means a number which is supposed to end with 10, if you factorize, it should have 2 as well as 5 as its prime factors. But can you see when you did the prime factorization of 6 to the power n that there is a 5? No, very clearly there is no 5. So absence of 5 very clearly indicate that there is no question that this particular 6 to the power n will ever finish with 0, right? That is the thing you have to now mention, right? So we'll write it very clearly with a formal statement. Please write this, wait and pause the video, and please make a note of it, right? Because in a board exam you need formal statements. Not knowing the answer or knowing the answer is not enough. Okay, so I'm writing that formally. Ye to hai hi already. So now next is what? 2 and a number with 0. It must be divisible by 10. Therefore, it must contain, or you can write its prime factorization must contain, whatever is, it must contain 2 and 5 as prime factor. Other factors may be there, but 2 and 5 are the must. But 6 to the power n does not have 5 as a prime factor, right? So what will be your conclusion? I think conclusion I should not write, right? So after that you can write the conclusion. That is for you. So please proceed to write the answer and complete it. And then similar problems can be written for you. Maybe like somebody asks you about 12 to the power and maybe say 8 to the power and any composite number which will not have maybe prime number like odd number also to be say 9 to the power n where this 5 will not be there. Okay, so they might ask you like this. So sometimes to make you confused, they may ask you, yeah, what may be the values of n so that this can ever end with 0. So here it is not a case. Only you have to talk about this. It can be any natural number, right? Because we are talking about positive integers, so we'll talk about the positive integers, but this should be definitely having a factor 5 and 2. Then only this whole thing will always end with 0. Okay, please mention I told you. Please observe this is positive integers, because if you simply say whole number, sometimes 0 will come here. So no matter what you put here, will always end up with 1. Okay, but of course n will not be 0 if you put at the top for value of m as 0. Anyway, that's separate issue. So I hope you have understood this. Now, yeah, come to this question. 24 and 360 are respectively the HCF and LCM of two natural numbers, one of which is 72. Then find the other. Very clear. So one number is given to be 72. Other number you have to find. We know their HCF and we know their LCM. Right? We know their HCF and we know their LCM. So now they are asking you to find what is the other number. Already you got a rule. You will write, we know that AB equal to product of HCF into LCM, and then do not put the value of this and do not multiply this. Simply you write B equal to HCF. What is the value of HCF? Is 2 for 24, and then LCM is 360, and then this value will be 72. So this will cut it by 3, and then this will cut it by 120. 120 is the other number. So that's the idea by what we'll proceed. Okay, so this can be a good potential problem for your board exam also, like this. Maybe one more called multiple choice. Okay, so here is the another problem. Examine if the following numbers are composite. So what does the word composite number mean for us? A composite number is a positive natural number which has more than 2 proper positive factors, right? Sorry, more than 2 factors, not more than 2 proper, more than 2 positive factors. So just you have to identify from here each number contains more than 2 factors or not positive factors. If you will be finding this, and fine. So let me take the first number. This is number 1. 3 into 5 into 7 into 11 into 13 plus 7 into 11. You need to multiply all this and simplify. One thing is very clear that this number cannot be 1. 1 से तो बड़ा है, Now from here, what you can take as a factor? 7 you can take, right? 7 is a prime factor. Now what will be left out? 3 into 5 into 11 into, okay, 11 also you can take out. I all like did not see this. Anyway, that's not an issue. One factor will be enough. So now can you conclude from here that 7 is a factor of this number? And very obviously 7 is neither equal to this number, right? Or 7 is not equal to 1. That means this number is having some other prime factors other than 1, other factors other than 1 and the number itself. So this 7 is a prime factor. So this will tell you, this implies what? You write it like this, then 7 into positive integer greater than 1 and greater than 1. Therefore, 7 is a prime factor of the number other than 1 and the number itself, right? So if this happens, what should be your conclusion? This should be composite, right? And next, how will you do? Very clear. You see, I should take some prime factors common, right? If you see, that can be broken as 3 into 7, and this you can see this can be broken as 3 into 5. So from both you can take 3 common or maybe 7 also. So in any way you will be getting either 3 or 7 as a common factor, or maybe you can take both. That is not an issue. Okay. Now come to this problem. This is an important problem. There are 3 alarm clocks which tolls after 6 minutes, 9 minutes, 12 minutes respectively. If all the 3 clocks tolls together at 9 a.m., then find the time when all the 3 toll it should be, S should not be there, toll again at the earliest. Also find the number of times each alarm tolls during this period. Did you understand the question? Toll means you can say that rings, alarms. If you set alarm, it rings, right? So it is given that the first, second, and the third clocks, they are ringing after every 6 minutes. That means at 9 the first clock starts ringing, then after 9:06, at 9:06, then at 9:12, at 9:18, like this timing period. Then second one will be 9:09, then 9:18. Third one will be after 12 minutes, it is 9:12, then 9:24, like this. So now if all the 3 are set in such a way that at 9 they all ring together, then you go on leaving the alarm clocks. Then after certain time, they all will again ring together. They are asking you what is that time, and by that time each clock rang by how many times. Okay, so what do you think? Just observe one thing. To write very short it is. Only I am explaining it. It is taking a little time because of that. If the first clock is ringing after every 6 minutes, so after 9, what are the time gap in which this clock is going to ring? It is these minutes. After 6 minutes, 12 minutes, 18 minutes, 24 minutes, like this. And then 9 minutes one you see, first 9 minutes, then after 18 minutes, then 27, then 36, then 45 minutes like this. Next one is 12, then it is 24, then it is 36, 48. Now you see, after 9 a.m. when you set the clock, leave the clock, then after this time first clock will ring, second clock will ring after this many minutes, third will ring after this many minutes. But out of that there is a common number 36. It is the lowest of its kind. आगे जाने से और मिलेगा common. But this number you can see. That means after passing 36 minutes, you will be getting again a common ring from all the three clocks. You have to find this 36. So what have you observed? It is the multiple. So you have to find the lowest common multiple. So for explaining this only, I took little time. Now what you will write, there is a statement. Please listen to it. I will not write this. If you miss it, review and play the video back. You should just write, since the time after which all the three clocks will ring together must be a common multiple of 6, 9 and 12. So the time gap will be found by taking LCM of 6, 9 and 12. Then you find LCM, right? Now LCM, I'll take this problem only. How to find the LCM by prime factorization method. So for finding LCM, you do the prime factorization of these numbers like this. 2 square into 3. In previous slides already we said LCM means all distinct prime factors you have to take which are involved in the whole questions, and you have to raise the highest powers. Here to only 2 and 3 you find. Now 2, what is the highest in all this? 2 is the highest. And for 3 it is 1, it is 1, it is 2, 2 is the highest. So this is certainly going to give you 36. So LCM is 36 means after 36 minutes. That conclusion again you write. Therefore, after 36 minutes, all these clocks will again ring together or toll together. So if they ask you at what time, then it will be 9:36 a.m. after 9. At the earliest means after 9 a.m. when next immediately. Okay. The second part, also find the number of times each alarm tolls during this period. Very nice. You divide 36 by each of the individual time, and that many times it will ring. Right? For example, it is told each alarm during this period. Sorry, not after. During this period means not. You have to include the 9 a.m. as well. So if you divide this by 6 times it will ring till 9:36. But at 9 they have already rang together. So first clock will ring for 7 times, right? It is for the first clock. Second clock you divide 36 by 9 4 times, and then 1 for 9 a.m. that is 5 times, and then for the third one by 12:36 for 3 times, then it's 4 times. Have you understood this? If you did not understand, please review it and try to do. This is important problem. This is important problem. This is important in terms of exam purpose, and this year onwards, this kind of questions are there in the main textbook also. Okay, next. A milkman wants to deliver 120 liters, 720 liters, and 576 liters to 3 customers. This amount of milks. He wants to measure all this amount exactly by some container. Suggest the maximum size of the measuring container. So now here you see, supposing you bring one container which measures 120 liters, then can you use 120 liters to measure 576? No. What is the reason? Because 126 doesn't divide 576. Something will be extra. Okay. So they are asking you what particular container, if you take, will give us such a scope where each of these we can measure a perfect number of times by that particular measuring container. Meaning is that the volume or the capacity of that measuring container should be such that it divides all the three. Meaning is that it should be a common factor. And as they are asking you the maximum size, so it should be the highest common factor. Right? So I think now I have given you the answer indirectly. Highest common factor you have to find. Anyway, I did not use the prime factorization for you, so I'll do the prime factorization. I'll go up to the HCF statement you cover, right? 120. If you write this, it will be 2 cube 3 into 5, right? I think it is correct. This is 8 3 are 24, 24 into 5, correct. Then 720. 2 to the power 4, 3 square into 5, right? Please check once whether I wrote the correct prime factorization or not. 576 is actually 24 square. 24 square. 24 square. 24 square is 24 is 8 into 2 cube. 2 to the power 6 into 3 square. Now, if somebody asks, please check once about the prime factorization. I did it already, so I might need HCF of these numbers. I have to find by looking at the common prime factors. Remember it. 2, it is everywhere present, so 2 I'll take. 3, everywhere present, 3 I'll take. 5, it is not present everywhere, so I'll not take. In case of LCM, you have to take everything. That's the difference. Please try to understand. Now, what I have to raise? The lowest power of these factors. In case of LCM, it was the highest power. So 2, it is 3, it is 4, it is 6. I have to raise 3. 3, it is 1, 2, and 2. So lowest is 1. So 24, right? 24 is that number which divides all these. It means if you have a container, a measuring container whose capacity is 24 liters, you can measure this exactly. By how many times? You can see this 3 makes 24, so 5. Whatever is the left out factor, that is the number of times. 5 times if you measure 120 liters. If you need to measure this, so from here you will find that it will be 6 more times, 30 times, right? And then this 24 times, because 24 if you divide, it will be 24 left out. That may be a additional part of the question. Okay, how many times you will use this container to measure 120 liters? So it will be 4 times like that. Okay. Now, can two positive integers have 24 as their HCF and 600 as their LCM? Explain. It is a very important question to check the basic, whether you are clear about the basic or not. Okay. Before you proceed for the explanation, it's an explanation of one line, but background you should know. That background I am explaining. HCF, when you found by prime factorization, you dealt with what? You dealt with product of, you will go back to the slide and you will please see product of lowest powers of common prime factors. Remember it. I am emphasizing common prime factors. And when it is the case for LCM, it is product of whom? Product of, you have to take the highest powers of all prime factors. All prime factors, distinct prime factors. If 2 is repeated, you should take only 2, 1, 2. Right? So now from these definitions, there is a very important observation to be made. Product of lowest powers of common factors of all the numbers, all prime factors. So what do you expect? Are all the factors involving in HCF also involves in LCM? Yes, exactly, because here it is only the common factors and here it is all factors. In fact, I can go back to the previous slide. See, if I find HCF, I have to take 2 and 3 and the lowest powers. If in this problem only LCM I have to find, I have to choose all the factors, right? 5 will be also coming, which is not here. That means whatever factors you got as prime factors for HCF, they are also very necessarily coming in LCM. Moreover, in LCM you raise the highest powers, right? So here it is 2. So if you raise highest powers of the prime factors, and here if you raise the minimum power, lowest powers, so very obviously each of these prime factors with their powers will be dividing this. Meaning is that LCM will be a multiple of HCF as well. That is, HCF always divides LCM of a number. That's the conclusion I should arrive at. That is, HCF always divides LCM, no matter how many numbers you have taken, what numbers you have taken. Okay, so here just you check, is this 24 dividing 600? Because if they are supposed to be HCF and LCM, then this LCM should contain all factors of 24, all prime factors of 24 with those powers. इसका मतलब 24 should be divisible by 600 should be divisible by 24. If you get, then it's okay. That means they can be, and if you do not get, they cannot be. Right? So that answer, please try to write yourself. And if you will be having any problem, again do discuss it. Today I'll finish it here only. We'll take more classes. We'll get into the next explanation, and then we'll do some other extra problems separately once we finish with the chapters. So for today, thank you so much, and please let me know to what extent you are able to follow the explanations. And I apologize, my handwritings are not that comfortable, so please try to adjust with this. Thank you so much.